Welcome to Build Free Hot Water at Home. I'm so excited to start this two-part series with you. This is part 1, covering the basics and materials for a DIY solar water heater. Let's dive right into the core concept of this project and what we're going to achieve. Think about your daily hot water use: showering, washing dishes, doing laundry. It all comes with a cost. But what if you could take the most abundant free energy source available, the sun, and use it to heat your water, completely eliminating that energy bill? This is what a simple DIY solar water heating system can look like. It's affordable, effective, and something you can build yourself. Why is building your own solar water heater a valuable project right now? Let's look at the impact. Energy costs are rising constantly. Heating water is one of the biggest energy consumers in the average household. Switching to solar not only gives you extremely low operational costs, but is also eco-friendly, dramatically reducing your carbon footprint. Whether you live in a suburban home, an off-grid cabin, or a rural area, solar water heating is a practical solution. It's reliable, requires minimal maintenance, and works effectively across diverse climates. Now that you know why it matters, let's look at the basic science behind solar water heating. The process is remarkably simple. Sunlight hits a dark, insulated surface. The black color maximizes heat absorption, and that absorbed heat is transferred directly to the water circulating through the system. Every solar water heater has 3 key components: the collector, which absorbs the heat, the pipes, which circulate the water, and the insulated storage tank, which holds your hot water until you need it. Solar water heaters come in a few different types, depending on complexity and budget. There are passive systems, which rely on natural convection to move water, and active systems, which require pumps and controls. They are both highly effective, but serve different needs. For our DIY build, we're focusing on a passive system. They are much simpler to construct, require fewer electrical components, and keep the material cost low, making solar heating accessible to everyone. Finally, let's review the basic materials we'll need for this DIY project. Gathering these materials is the first step to starting your build. You'll need black tubing, ideally PEX or polypipe, to absorb and carry the heated water, and a wooden board or frame to house the collector. We'll also need a clear plastic or glass cover to create a greenhouse effect, trapping the heat, and a water tank or container to hold the supply. That covers the basics. You now understand the science, the necessity, and the parts required. Make sure you have these materials ready, because in part 2, we'll build this system step by step. Welcome back. This is part 2 of our series, where we finally dive into the hands-on guide for building your own DIY solar water heater. Before we start cutting wood and laying tubing, let's have a quick recap of the concept and the materials we gathered in part 1. Remember, the core idea is simple. A collector box absorbs sunlight, heats the water circulating through black tubing inside, and uses natural convection to move that hot water to a storage tank. All right, enough talk. Let's get our hands dirty. We are building the solar collector box first. The collector box is the heart of the system. It houses the tubing and captures the sun's energy. Step 1, building the base and frame. Cut your lumber to size and securely assemble the perimeter box. Make sure your dimensions accommodate the length of your tubing. Step 2, installing the black tubing. Lay your black plastic or rubber tubing in a coil or zigzag pattern inside the collector box. Use close-up shots here to show the dense layout. Why black tubing? Black materials absorb nearly all the wavelengths of light, converting that energy directly into heat. This is crucial for maximizing the water temperature. Step 3, connecting the inlet and outlet. Make sure the inlet pipe is at the bottom of the collector and the outlet pipe is at the top. This supports natural convection. Cold water enters at the bottom, heats up, and naturally rises to exit through the top outlet. We need to clearly show this water flow direction for an efficient system. Now that the heart of the collector is ready, let's seal it up and connect it to the rest of the system. Step 4, adding the transparent cover. This clear lid, often plexiglass or polycarbonate, is essential for trapping heat inside the collector. This transparent cover creates a miniature greenhouse effect. Sunlight passes through, heats the black absorber, and the cover prevents the heat from escaping back out, supercharging the temperature gain. Step 5, connecting to the tank. For a simple gravity-fed system, make sure your storage tank is positioned higher than the collector. Hot water naturally rises and flows into the tank. Building a solar water heater is straightforward, but a few common mistakes can drastically reduce its efficiency. Let's cover those now. First, poor sealing. Any air leaks in the collector box or around the cover will allow crucial heat to escape, reducing your water temperature dramatically. Seal everything thoroughly. Next, positioning. Ensure the collector is angled correctly for your latitude to capture maximum direct sunlight throughout the day. South-facing is usually best in the northern hemisphere. Finally, avoid using non-heat resistant materials. The collector gets extremely hot, so all components, especially the tubing and adhesives, must be rated for high temperatures to prevent failure. Congratulations! You've completed the build phase of your solar water heater. The hard work is done. Take a moment to review your finished collector and tank setup. Ensure all connections are tight and everything is securely mounted. Now let's test it and see how well it actually works. Welcome back. In this third part of our DIY solar water heater series, we're finally answering the big question: does it really work? We're testing the system, analyzing the results, and planning some major upgrades. Today's video covers the system setup, crucial temperature tests, and how we can improve efficiency for even hotter water. Stay tuned to see the results. First things first, system setup. A successful test starts with proper positioning. We need maximum solar gain to get the best result. The most important step is placing the collector panel in direct, unobstructed sunlight. Any shadow will drastically reduce the efficiency of our heater. We've adjusted the collector to the optimal angle for our location, ensuring it faces true south and matches the sun's altitude for peak performance during the testing hours. This angle is key for maximizing energy absorption. Now for the moment of truth, testing and results. We're tracking the temperature changes to see exactly how much heat our DIY system can generate. We started with a baseline water temperature, and now, after 4 hours in the sun, we're checking the final temperature. The difference is significant. Here is a time-lapse showing the heating process. You can visually see the temperature gauges change as the collector absorbs more solar energy over the hours. And here is the hot water output. With an initial temperature of 60 degrees Fahrenheit, we reached a peak of 115 degrees Fahrenheit. That's a 55-degree rise, which is excellent for a DIY system. While the results are promising, we always look for ways to improve efficiency. Let's discuss a few upgrades that could push our system to the next level. The two main factors are reducing heat loss through better insulation, especially on the storage tank and pipes, and increasing the collector's surface area to capture more sunlight. Finally, fine-tuning the collector's angle throughout the year is crucial. Adjusting it seasonally to match the sun's path will ensure maximum energy absorption regardless of the time of year. So where can a simple DIY solar water heater like this actually be used? The applications are broader than you might think. It's perfect for supplemental home heating, but also incredibly useful for outdoor applications like heating pool water, warming water in barns, or even just for an outdoor shower. For off-grid living, this system is a game changer. It provides a simple, energy-independent way to meet basic hot water needs without relying on electricity or propane. To wrap up, our DIY solar water heater proved that simple engineering can lead to great results. It's effective, and with a few upgrades, it can be even better. The core benefits are undeniable: free energy from the sun, a simple build using accessible materials, and a truly sustainable solution for heating water. We've shown you how it's done, now it's your turn. Try building your own and share your results in the comments below. If you enjoyed this video and want more DIY sustainable projects, please like, share, and subscribe to our channel for all our latest updates.